Whilst many people today envision the Middle Ages as being rather abhorrent, with few gains being contributed towards the human endeavour, this description rarely proves to be the case. However, it is to the east, within the burgeoning Islamic Empire, where such inaccuracies become most evident, as it was during this time that a golden age of tolerance, multiculturalism, education and wisdom began to unfold in the region. A period of enlightenment that not only fueled the Islamic Empire from the 8th century up until the 13th, but which also led to the birth of many ideas that still influence our world today. From scholarly writings on the topic of evolution 1,000 years before the birth of Darwin, to the invention of algebra, this cultural melting pot became one of history's most influential voices. Primarily because, in contrast to the guarded nature of Christian teaching adopted in the West, the holy text of Islam instead encouraged a worldly education, regardless of origin, age or source. And so, under the reign of Abbasid Caliph Harun al-Rashid, a movement began that sought to both acquire and translate teachings from the four corners of the empire, from the scriptures of ancient Greece to Egypt, Rome, Babylonia, India, Persia and China. Indeed, if it had not been for this golden period of enlightenment, we in the West may have never even heard of Aristotle. And whilst the idea of the ether, or quintessence, as it was then referred, remained a mysterious source of alchemical magic, it was in this environment that Plato's extramission theory of sight was re-examined. Abu Ali al-Hasan ibn al-Haytham is known today by many pseudonyms, not least of which the world's first scientist. Though he did earn one other honorary title relevant to our story, that being the father of optics. So the story goes that upon failing to provide his host, the ruthlessly unpredictable Fatim Caliph al-Hakim, with a viable solution to the periodic flooding of the Nile, Ibn al-Haytham, in fear of losing his life to the whims of his host's bad temper, decided that, despite his genius, he would plead forgiveness under a case of insanity. And it worked. Successfully avoiding his corporal punishment, Ibn al-Haytham was instead sentenced to the lesser punishment of a 10-year stay in confinement. However, as devastating as this was, historically it was not for naught, as it was during his time of imprisonment that he had a revelation. Within the dark confines of his four walls, Ibn al-Haytham's mind wandered, moving in and out of the present moment, as one does, until his attention was struck, taken by a stray beam of light shining through a small hole in his cell wall. Upon paying closer attention, he noticed that as this beam came to land upon the opposing wall, it cast a peculiar, yet somewhat familiar image. Though it was upside down, he realised that this image was in fact a reflection of the outside world. Whilst many of us may have simply dismissed the curious effect, Ibn al-Haytham chose to consider the meaning behind this play of light, thus inspiring an idea that came to form the basis of one of his most influential works, the Katib al-Manatzir, known in the West as the Book of Optics. From this experience, Ibn al-Haytham devised an experiment which not only introduced our modern scientific ideals of falsifiability, replicability, and evidence for causation, but which also used such evidence to provide proof for his theory that light must travel in straight lines in the direction of its source. By simply placing a pinhole in the wall of any dark space, he was able to show how light must travel in vertical lines from the upper edge of the outer sunlit image towards the inverse lower edge of the inside dark wall, and vice versa, from the bottom of the outside image up towards the top of the inside wall. Thus, by devising an experiment that restricted a path of light through a pinhole, the outside image would be revealed inverted on the opposing wall, precisely as it had done in his cell. This he called his al-Bayt al-Muslim experiment, translating simply to dark room experiment. Although it is the Latin translation of camera obscura that we derive the name for the technology that it would go on to inspire. And if this wasn't already enough, not only did he prove that light travels into our eyes rather than out of them, but he also went on to explain how the image we see is a psychological one, created within the mind of the observer. In the centuries to come, Ibn al-Haytham's Book of Optics continued to remain the dominant text on light and optics, inspiring the likes of Copernicus, Kepler, Galileo, Descartes, and even Isaac Newton in his own revolutionary work, Optics, published in 1704. But it was Newton who would once again change gears in the ongoing wave-particle debate. If you enjoyed that and you would like to watch the next part, I'm going to put the links below. Otherwise, the full 1-hour deep dive into the history of light is currently available on our homepage, so feel free to check that out. Otherwise, much love, and I hope you all have a wonderful, wonderful week. See you later.